Good morning, good afternoon, and good evening, everyone. Thank you for joining us for the Halo RSS webinar. Um, we're very excited to see you all this today, and we hope that you really enjoy our presentation. To get us started, I just want to say a little bit about scientific drilling. Here at Scientific Drilling, safety is one of our core values. So much so that we've been able to make it an entire year without a recordable incident. And one of the ways that we demonstrate this value is our commitment to beginning and presentation with a safety moment. And so today, I just like to challenge you to think about safety outside of the workplace. It's easy for us to go through our daily lives whenever we're working and think about safety as it relates to our industry. But we really want to encourage everyone to be safe at home and to live safe as well. So at this time, I'd like to introduce you to Ken Webb, our MWD product line manager, and he's going to talk about what we do to ensure our MWD reliability and how we've increased MWD reliability over the years. Ken became the district operations support in the Northeast District and eventually became the Southern Regional Operations Support Specialist. Before his promotion to MWD product line manager, Ken worked for 4 years as MWD product line champion with Scientific Drilling. He is a veteran, active duty veteran of the United States Air Force, where he served as a munitions systems technician and inspector. And he currently serves on the board of directors for the Lafayette, Louisiana cycling community. All right, Mr. Ken.
Hey, Ben, can you hear me?
Yes, sir.
All right. Good day, everyone. I would like to personally thank you for joining today's webinar. This webinar is intended to show our current customers and our potential customers what we do within scientific drilling to actively increase MWD reliability. This webinar is not intended to be a technical webinar about how MWD functions, but if you would like some additional information about the functionality and the capability of our MWD tools and any of our other service offerings, you can simply visit our website at www.scientificdrilling.com, as it does contain our contact information to get you the answers and the services that you need. All right. Let's see if I can. All right. So scientific drilling, we always like to start out with a safety moment. I'm hopeful and I'm pretty sure that everyone has heard enough about the importance of washing your hands during these times. So for today's safety moment, I'd like to raise some awareness about suicide prevention. During these unprecedented times, we can all get wrapped up in our own self-isolation bubble. Recent statistics have shown an 800% increase in calls to the U.S. suicide hotline. Stats are also indicating that the suicide rates are extremely close to the Great Depression time period. A study done by the World Health Organization indicates that for each suicide, it's also accompanied by 20 suicide attempts. Some of the contributing risk factors are today's economic stress, social isolation, decreased access to community and religious support, decreased access to mental health treatment, and of course, the national anxiety about today's COVID-19 and unemployment rates that we're seeing on the news constantly. So I would like to personally challenge all of you to check on at least 3 people today. Check on your family, your friends, your peers, your coworkers, and then challenge them to do the same thing. You can simply save someone's life by calling on them. You never know what's going on out there. And then for any of the people that need to talk to someone, the National Suicide Prevention Hotline, 1-800-273-TALK is always available and ready to talk to you. Before we dive into our processes, which we use to increase reliability, I feel it's important to showcase the experience that scientific drilling provides in our tool development. Highlighted on the screen is a timeline containing snippets of achievements over the past 50 years. And of course, one slide, it just simply won't encompass the entire timeline of achievements in complete detail, but it does provide the value of illustrating over 50 years of engineering, research and development, manufacturing, and service delivery from Scientific Drilling's products. Scientific Drilling's MWD engineering and manufacturing support occurs primarily at our Applied Technology Center in Paso Robles, California. Halo Rotary Steerable Technology is supported by our guys in the Cella Technology Center in Germany. Contributions from that team is also being made towards Scientific Drilling's next generation MWD tools. Our engineering group includes electrical, mechanical, software, and firmware engineering teams, and they work hand in hand to fully conceptualize and deliver the exceptional equipment that you've seen from Scientific Drilling. Upon commercialization of MWD equipment, these teams ensure our full manufacturing capabilities continue to meet the quality demands that our field operations group need to deliver exceptional service quality. In the event of a tool needing diagnostics testing for customer reporting, we have full diagnostic capabilities to determine the exact root cause of failure down to the circuit board and sensor level. In an upcoming slide, we're going to talk about Hello. All right. So in an upcoming slide, we're going to talk a little bit more about our standardized non-conformance reporting system used by Scientific Drilling. And that way we ensure that we're capturing all of this, all the failures systematically, client report generations processed in an efficient time frame. Our drilling engineering team located at our Houston Technology Center works with client drilling engineers to help improve BHA selection for mitigation of vibration, stick slip, high frequency torsional oscillations, otherwise known as HFTO, bending fatigue, and other systematic BHA failures. Dr. Josh Wilson's webinar that he put on last week highlighted some of their capabilities into the services that they do perform to decrease BHA failures. This webinar should be available. Well, actually, it was released earlier today, and just in case you missed it last week. Scientific Drilling also provides global survey management to improve wellbore placement in areas with magnetic interference or tight wellbore spacing for well site efficiency. So calibration verification of sensors, to me, it's the crucial foundation for MWD reliability. Having sensors which are providing erroneous data feeds simply compiles into incorrect wellbore placement, unreliable KPI reporting, and it hides failure mode details. Sensor verification is usually confined to survey sensors and LWD sensors such as gamma, resistivity, sonic, but realistically, all other sensors within the MWD, such as temperature, RPM, vibrational sensors, pressure, they all serve an equally important role into the data analysis performed to increase tool reliability and drilling performance. During each pre-run tool check, operators must perform validation testing for each sensor within the tool string. That way they ensure the accurate and thorough tool functionality is there. These validation checks and all calibration verification documents are also permanently recorded within Scientific Drilling's MWD software, and it's available for client distribution. Introducing continuous improvements while increasing tool reliability realistically doesn't go very far, in my opinion, if we're not performing proper training. Keeping and improving reliability heavily depends on thorough training. Having an in-depth knowledge of the full inner capacity of our tool components, Scientific Drilling's training department is completely involved with product line teams and key support groups to continuously update course development. Training courses are designed from work instruction documentation, which is also continuously updated and distributed to ensure best practices are followed. Initial operator training focuses on safety, tool maintenance, calibration verification, tool running best practices, and communication. Communication should be focused on for a minute here, as this pertains to daily feedback about tool performance to the district, updating rig site timelines for coordinating efforts, but more importantly, the need for communication and acknowledgement from the well site leader and driller on the rig site about improper tool use that could lead to any type of tool malfunction. As part of the continuous training process, operations and engineering support teams use features built in to Scientific Drilling's proprietary decoding software known as Data Model. to play back transducer data and analyze frequencies visually within the built-in spectrogram that you see on the middle of the screen right there. This allows for real-time, immediate, post-well, and historical analysis review of files with hydraulic problems, such as agitator setups and other interfering noises. The historical analysis also allows additional BHA configurations used globally to be scrutinized for vibrations, flow restrictions, and formation evaluations. The software also allows for a secondary decoding computer set in read-only mode, which uses the same primary surface equipment to perform real-time filtering without risking decoding degradation. This read-only mode is also used for training newer operators and for testing new decoding software in parallel to the current decoding platform. During our drilling operations, a drilling dynamics message is pulsed up every 2 to 3 minutes, which allows a light traffic light style visual display to effectively monitor vibrations, stick slip, and temperature. This is extremely effective and efficient in both rig operations out on site and remote center operations. These levels can also be sent out via WITS, whether it's WITS level 0 or WITS ML, on the rig's EDR system to monitor on the rig floor or by the drilling engineers in an office setting. Scientific Drilling does provide a printout as seen on the right-hand side of the slide, which defines the meaning of the levels, and it also includes some recommended actions to lower the higher vibrational levels. For any areas where we're anticipating higher vibrations, message tables can be programmed within the MWD tool and selected to pulse up real-time actual vibration and stick slip numbers. After extraction of the MWD tools, operators are responsible for downloading the memory data from the MWD tool. The data is combed through to ensure that sensors performed as designed and timestamps match for log distribution. These logs and data verification also serve as part of pre-run checks before using the tool string again. This slide details the vibrational levels seen during the transition from sliding over to rotating. And I mean, it basically indicates a need to mitigate the unnecessary vibrations during the transition. That way we're preventing damage to the BHA and MWD components. Comparing the memory data to the real-time levels pulsed up to surface details the validity of the levels pulsed to surface, and it also increases the data density for insight to the cause and mitigation of the vibrations. In the event of a tool not performing adequately, or if any of the other components were subjected to out-of-spec conditions, Scientific Drilling's in-house non-conformance reporting system, named Bullseye, is used to initiate an NCR out on location, and then it's also used to track the NCR through the entire process, from root cause identification all the way through customer report generation. The information collected through this process is also used in sustaining engineering efforts, and it's used in the client review process. The Bullseye system is consistently monitored to maintain workflow and reporting time efficiency. Reporting tags, as pictured on the right side of the screen, is used for clear do not use identification, and they're included in the MWD kit boxes to prevent reuse of tools involved in a non-conformance. Upon returning to tools to the district locations, each district office has a designated NCR area for ease in identification and to eliminate from reuse. Tools with an NCR tag are returned to the appropriate manufacturing facility for diagnostic evaluation and refurbishment cycles. Upon completion of the well, Scientific Drilling's data model file will be uploaded to its cloud-based server known as Central Data Model. This system not only permanently stores all of the real-time and memory data, but it also mines the data to apply tough points to the tools which were used downhole. Tough points, as you can see, is labeled as tool utilization factor. And it's also a proprietary environmental-based condition system to determine a maintenance cycle to electronics. So basically, we're establishing a life cycle to the electronics. This maintenance cycle eliminates downtime and it increases productivity by not running a tool until it fails. The point-based system establishes thresholds for individual tools, and it applies a multiplier of points based on the exposed vibration, temperature, and stick slip levels. The higher the levels, the faster they accumulate points. Upon getting close to this threshold, districts receive an email every Sunday indicating which tools are within 75% of the threshold. That way they can start to plan for a fresh replacement of the tools. These tools are identified as nearing the end of its life cycle, and they're sent in to Scientific Drilling's manufacturing facility, and then they're rebuilt to a new status. Scientific Drilling's regional diagnostic program empowers each operator on site and at districts with the ability to perform a full maintenance analysis on each component within the tool string. Operators and shop technicians have step-by-step instructions to perform electrical continuity tests, electrical insulation testing, contact band pull testing, and these tests, of course, involve verification of calibration for any sensor packages within the tools. This program right here is one of the main highlights when we offer in-house displays to our clients' drilling engineers, and I would personally like to offer any of your team after we get out of the stay-at-home mandates for the COVID-19 to go ahead and schedule an MWD demonstration. This gives anyone who has never seen an MWD tool some hands-on with building, programming, and maintaining some of the equipment. You'll also see our efficient footprint out on the rig site, and ultimately you'll see what we do, how we do it, and why we do it. So quickly reviewing what Scientific Drilling consistently performs to increase tool reliability, each item has one main contribution that it relies on, and that's good data. Good data results in reliability. Reliability results in cost effectiveness, and cost effectiveness results in profitability for everyone involved. Using the standard practices and procedures we discussed in this short webinar, Scientific Drilling has increased its reliability and its success stories. While drilling conditions constantly change to drill faster with increased challenges, we are and will continue to improve reliability using Scientific Drilling's 50+ years of engineering and service delivery experience. For any additional success stories, case histories, contact information, questions you may have, you can visit our website at www.scientificdrilling.com, and you can subscribe to our social media platforms such as LinkedIn, Twitter, YouTube, and Facebook for up-to-date information. I want to thank you again for joining today, and let's turn it back over to Ben Jones for any questions you may have.
Thanks, Ken. Great presentation there. As Ken said, now it's time for question and answers. If you have any questions you would like to ask, feel free to ask them aloud, or go ahead and drop them in the chat. We're monitoring the chat there, so whatever's more comfortable for you. I do have one that came in via email from the meeting earlier, and I wanted to go ahead and address it here, Ken. So we talked a little bit. You spoke a lot about what happens in the shop and how we do this calibration. Can you explain to the attendees here, what does the calibration check process look like for a field engineer out on a job?
So the field engineer actually has a couple of different options that he can choose from. He has the ability to check calibration especially for the MWDI, which is our survey package, out on location with a lithium battery, a couple of barrels, and then a connector. The gamma probe itself, and anything that has gamma and needs a source to verify it with, will need to be sent into the district location, and that can also be done with the survey package as well. They can send it into the district location, and they can receive a fresh one out into the field with the calibration documents and such. And that's one of the things that we like to highlight whenever we're hosting any of the drilling engineers into our district offices and such, is to teach them what to look for calibration documentation and any kind of verification, and to actually ask for it. It doesn't matter if you're running scientific drilling or if you're running any other service provider. They should be able to prove that the calibration was verified and checked, and they should have documentation for that. So, and that's one of the things that we pride ourselves on, is being able to provide that documentation for them.
Good deal. Thank you. The next question here is, can you go over the stats and the runs shown on slide 13 in the Permian, and why is that significant?
Let's see, for the Permian right there. Oh, okay. Yeah. So yeah, 100 plus days with no trips for failures. What's significant about that is, about a year ago, we had a significant amount of failures that we were seeing because of different drilling conditions and such like that, especially with our pulsar. And after attending an MWD conference and such like that, it wasn't just scientific drilling that was facing these challenges with especially with the pulsar. So since then, over the past year, our sustaining engineering group, along with our pulsar technicians and such, have been working hand in hand to redesign the inner workings of the pulsar. Now, our pulsar is a self-compensating design. It doesn't require any calculation of a poppet or an orifice. So we have 5 different pulsar sizes and such. And so we took the 2 main pulsar sizes in that area, and we actually redesigned the inner workings, the flow area, changed out some of the materials and such. And we went from having about 25 failures a month or so for a short period of time to 100 plus days with no trips for failures. And since this was released March 20th, that is still the only failure that we've had in the Permian Basin right there. We're still, as of today, we're still ongoing since that one failure. So that's in my book and in anybody else's book, that's a pretty impressive stat right there.
Definitely. Yeah, I think as of today, it's 149 days with one failure, and up in the New Mexico, Colorado area with our EM tools, we're getting close to 250 days without a failure. So that's some good reliability showing through. The next question is a text in from Pete. What are you doing around remote MWD and reliability?
So what are we doing around MWD, remote, and reliability? So over the past 7 years, since we've rolled out our data model software, which is our decoding software and such, we had the vision years ago, and we've been running remote operation centers for 6-7 years in some locations, and we had the vision back then that remote centers were going to be the future. And so what we're doing to drive towards much more efficiency is, you saw on one of the screens that I talked about the drilling dynamics message, and well, you can see the entire screen right here, and seeing those traffic lights and such like that to make sure that we're providing efficiency for the operators and such. That way they can see what's going on just by glancing over at the screen, and they can see whether the vibration levels need to be checked or the stick slip levels need to be checked. And then right underneath each traffic light, this little bar right here represents the past hour of what was going on for stick slip, temperature, and any of the other readings on there. One of the other recent innovations and improvements that we've made to the software as well is if you do start to have some kind of issue to where, let's say you start getting a communication error or some type of bus line error, the readings on that are pulsed up to surface, if it's an erroneous error of some sort, will actually be highlighted in orange or red, depending on the severity of the error itself. And then one final thought on that is we also, as far as the networking and such, typically, you have one decoding system doing this, and then you have another software package doing the survey calculations, and another survey or another package doing the logging collection and such like that. Our system is all in one. It utilizes one server. It's all tied together. There's no putting a survey here and then typing in another survey into the logging system. It's all derived from one point, one location. So one entry is all it takes, and and that's driven its efficiency as well.
Thanks, Ken. The next question here from Ty. Does your pulsar operate off of positive or negative pressure pulses?
It's a positive pulse system. Yes, it is.
Okay. And can you please explain tough points a bit more? Is the tough points based on pumping hours? Is the tool pulled off service once the tough points are reached?
So tough points is basically exposure to downhole during a certain time period. Our system marks that it was downhole from this time period to this time period once it's extracted. And during that time period, anything that it's exposed to as far as temperature, as far as vibrational levels, axial and lateral, and stick slip, it's assigned a multiplier based on the severity of that value that it saw downhole. So if for instance, we take our MWDI, our survey package, and we say, okay, it's got 75,000 tough points. Well, when the tool goes in for a tough rebuild at our Applied Technology Center, it's rebuilt to a new status, so it comes back with 0 tough points. And so as it's exposed to downhole environmental levels, those tough points begin to accumulate. And again, once it gets to about 75%, or once it gets to 75%, the district is notified and they start planning to get it replaced.
All right, good deal. Thank you. Let's see. Next question there is from Nick Allenby. I'll actually take that. Nick wants to know how many assets we assign to a client. Nick, we usually send out 2 per client, and we find that works really well for us. But our tool is SON based and modular, so we definitely have the ability to maneuver that around quite a bit if we needed. Next question there. What's the importance of NCR, Ken?
Oh man, tracking the NCR, from its failure time all the way through its reporting back to the client. That's the importance of an NCR. Getting back to the client with, okay, look, this is what happened. This is why it happened, and this is what we're doing to make sure it doesn't happen again. That's the importance of an NCR, and following through with everything in between, because the NCR system Bullseye that we do use, again, it's consistently monitored. We get hammered on pretty well at any stage of the NCR process if it stays in a queue too long. And then depending on the severity of it, we assign appropriate priorities to those NCRs, because if we have a client that's waiting on on documentation review or anything like that, we assign an appropriate priority to that tool to make sure we get it in an efficient time manner.
Thank you. Let's see. Sorry, that previous question was from Ahmed. The next question is from Oliver. What is the data rate speed range of your MudPulse tool?
So we can go as slow as 0.25 bits per second, and then we can get up somewhere to, in a perfect scenario, with no noise and everything like that, we can get up to about 5 bits per second. But typically with pump noise and such like that, we're less than slightly less than 2 bits per second right there.
All right. And how does that equate with when you talk about the EM tool? What's the difference there?
That's a good point, and that was only for the Mud Pulse tool. I'm glad you mentioned that. With Mud Pulse, somewhere around the 250 millisecond range, that gets it down to about two bits per second, and then all the way up to right around like 14.6 bits per second with 32 millisecond bipolar. And we've had great success running bipolar 32 millisecond, which is our fastest telemetry in EM in the Marcellus Shale with oil-based mud, and in the Grand Junction area and such like that. We've had great success with it right there. Typical downlinks and such for EM is about 16 seconds. We can change to 3 different telemetry speeds with EM by downlinking. We've got 10 different program messages we can downlink to, amongst other things that we can downlink. Mud Pulse takes on average about 5 minutes to downlink. And with Mud Pulse, we have a much larger range of pulse widths that we can select from. We actually have 10 that we can choose from to get around any kind of noise or any kind of situations along those lines. And the best way to look at what range you want to be in is simply looking at the spectrogram that you see right here to see if we have any frequencies that are intruding into our bandwidth.
Right. And I know you mentioned, the places that we're being successful with EM. What are we doing to try to get EM to work in the Permian?
So we've actually had great success with EM in the Permian over the past year with our EM deep receiver. We do have an EM deep receiver that gets placed into an existing wellbore. We prefer non-producing. We can do producing, but of course with safety, and exposure to operators and stuff like that, we do prefer non-producing wells. But we've had great success in the Permian Basin. We've done it in the Bakken region as well with a few clients with tremendous success as well.
Great, thank you. Another question from Ty. He wants to know if our pulsar can handle both magnetic and gyro MWDs on the same BHA.
Absolutely. Anytime we run gyro MWD, we also have a magnetic sensor package in there as well. Any MWD tool string that we run, whether it's Mud Pulse or EM, will always have a magnetic survey package within it. Yes. And you can choose to pulse up either a simple gyro survey, or you can do the magnetic survey, or you can do both, which is typically what we do. We typically send up both surveys for comparison. That way we can see when we start to get away from magnetic interference, and then go from the gyro over to magnetic.
Perfect. And in that EM deep EM receiver setup you were talking about, how far can the EM receiver be from the well that's being drilled?
We've done I think the furthest one that we've done is close to about 5 miles. They were somewhat pointed towards each other, but the EM deep receiver does not go into the lateral of the wellbore that it is placed in. So I don't think that had much of an effect on it, that it was actually pointed towards the other well. But yeah, we've done one close to about 5 miles out. And we've done quite a bit with some 2 miles out, 2 to 3 miles out. We've had a lot of success with that as well. But as long as you get the deep receiver below that limiting formation, whether it's a resistive formation or extremely non-resistive, that's ultimately the key.
Well, that kind of leads into the next question here from Oliver. His question was, what was the TVD limit for the EM tool?
That is the $1 million question right there, and that depends on where you're at. What region are you in? Every region is significantly different. We've had sometimes in South Texas, when you get below 2,000 feet TVD, your EM signal's gone with traditional ground stakes and such like that. We've had success in the in Colorado area to where we were 15 and some down to 17,000 feet TBD, and then everything in between with that. And then sometimes your drilling fluid plays a large part in the capability of that as well. You know, for example, in the Marcellus Shale, as soon as your gap sub enters the Marcellus Shale with water-based drilling fluid, your EM signal turns off like a light switch. But if you're using oil-based drilling fluid, you can drill a 10,000 foot lateral without any problems at all on 32 millisecond pulse width.
And Ken, just for clarification, I mean, since we're talking about the EM tool and you know some limiting factors, why are those formations limiting for the EM tool?
Well, you've got some formations that are extremely resistive, you know, and an EM tool, electromagnetic tool, you know, it's basically injecting electricity into the formation. So it's the same reason that you don't use rubber wire to turn on your lights inside the house. Electricity obeys the law of physics, and you can't inject electricity through rubber. You know, and some formations, I'm not saying that there's rubber down in the formation, but some formations are just as resistive as that, to where you've got, you know, 2,000, 4,000, 10,000 ohms of resistance and such. And then you also have on the opposite end of the spectrum, electricity follows the path of least resistance. So if you have a salt layer in there, a salt zone or something like that, that's extremely non-resistive. And therefore, instead of going all the way up to surface, once it hits the salt zone, it just simply goes sideways into the salt zone. It never makes it up to surface. So Oliver, if you would like, reach out to me, you know, as Ben's going to have actually on the end of the screen, ken.webb@scientificdrilling.com. And we can pinpoint what your TBD limits are for the locations that you're wanting specific information about.
So thanks, Ken, and Oliver. Again, if you need anything, feel free to reach out. Ken, what would you say are calibration standards?
Well, calibration standards. So, you know, we have a spec sheet that we provide, you know, to everyone. You know, it's available on our website and such. Our calibration standards, you know, whether it's you know, for the survey package and such, or whether it's an API standard for any gamma probes and such. You know, I mean, you've got strict standards that you have to adhere to. You know, because we've gone out, you know, for let's bring up ranging applications and such like that. You know, you get a blowout on your well, you know, and you've got to drill another well to plug up the well that's blown out. You know, and we've gone out there, you know, and we've had we've asked for their surveys and such, and you know, we personally, I didn't know that some service providers actually offer a tool without calibration. You know, and imagine trying to range or drill towards a well where you really don't know where that well is at. You know, so I mean, that's just one small, you know, piece of the puzzle right there, and one of the many things that could happen with bad surveys or bad calibration and such. You know, if you have any of your other LWD sensors in there, and you drill a pilot well, and then you're trying to pick that formation top or something like that, you know, I mean, that's gonna you've got a lot riding on that.
So is there an industry standard or expectation when it comes to MWD surveys?
Oh, definitely, definitely. You know, you've got error models and such that that your tool has to meet. You know, and obviously ours is you know, very tight tolerances and such like that. You know, and we're one of the tighter spec MWD services providers out there for survey and such like that. We our MWD operators have a much more stringent, plus or minus on A totals, our gravity totals, magnetic totals, and such like that. That way, whenever we do provide the final survey report to any of our clients, we are within the error model or a lot better than what that error model is actually saying. And then, of course, with gyro MWD and such, those error models are significantly reduced because of the type of tool that it is.
Okay, thank you. Let's see, is this the same MWD tool that you use in your rotary steerable systems?
Yes, absolutely. The MWD tool, the Mud Pulse tool, is currently the only telemetry type that we have integrated into our Halo. Our engineering teams are currently working on the integration of EM into our Halo tool string as well.
Okay, thank you. Next question here: Has Tough Points been validated? Has Tough been validated against actual tool MTBF?
Yes. So we within the company, we do have graphs and is it Alvaro? Again, reach out to me. We can have a meeting and such like that. I can show you some of the graphs that we do have that shows where we were at prior to 2012, and then once we introduced Tough Points, and how significant the drop off of errors per month or failures per month that we did see. As far as electronics, which is what Tough Points is mainly attributed to right there. On our electronic side, our MTBF has skyrocketed because of Tough Points. And again, I brought up the situation about, about a year ago having pulsar issues and stuff like that. We all go through our, failure modes and such like that because of changing conditions and stuff. But it definitely utilizing the NCR system, Tough Points and everything along those lines. That's where it's all attributing towards MWD reliability.
Okay, along those same lines, and you may have just answered it. How many years has SDI used the Tough Point system?
So we officially rolled out Tough Points back in 2013. We did spend a year, a little bit longer than a year, actually bucketing and looking at the data and deciding how we were going to bucket all of the information and how we were going to establish thresholds and such. But we utilized all of the historical data that we had within the system prior to 2013 to go ahead and start bucketing information and start looking at, okay, if we turn this on, what's it going to do? How many tools are actually out in the field right now that are going to get recalled and such like that, and then we also wanted to make sure that we had an established threshold that we could identify with tools out there and not prematurely send a tool in, because if we're prematurely sending a tool in, and it realistically still has half of its life cycle left, and that drains the cost effectiveness right there, and of course we don't want to pass on any unnecessary cost to anyone that we don't have to. So we spent a lot of time looking through that data. That way we can establish a life cycle, an appropriate life cycle. And it's not by all means an ended project. This is definitely something that is dynamic, that we're consistently tweaking, consistently making better as we make improvements to the tool. We've noticed we've extended the life cycle of some of the components, but it goes through a strict process and such like that to where we're making sure that if we're going to extend the life of a tool, we're not doing it erroneously.
Great, thank you. And then I've got a question via email, and I don't see any more in the chat right now. But question via email: How long does Scientific Drilling archive their survey data?
Yeah, it's there forever.
Okay. Yeah, once it's uploaded to Central Data Model, it's not going
Right.
anywhere, right?
Right.
So
And that's,
stored in the cloud indefinitely.
that's since we've rolled out data model, central data model, which is right around that 2011 time frame, if I remember correctly. I remember testing data model back in 2011, so somewhere around the 11 to 12 time frame. Now, if we do have anyone out there that's looking for survey data, we had some inquiries from Norway for survey data that was back in 2006 last week, actually. And even though the Norway district has closed, all of that, all of those records and such have been moved over to Aberdeen, which is the European centralized headquarters over there. And we were able to get the client the information and the survey data that they needed from 2006.
That's
And that's
great.
prior to central data model. So yeah.
Perfect. Perfect. All right. Well, that's going to just about wrap us up today, folks. Thank you so much for joining us. Again, we've recorded this webinar. We will make it available for you. You'll get a link with the link. Excuse me. You'll get an email with a link to the recording, so you can watch it, share it. Please feel free to reach out if you have any questions at all. We'd love to answer anything that you have, and just to be a source for information for you moving forward. We will have some more webinars coming up. We don't have another one next week, but the week after, we do have Laura Peary, who's our product line champion in our wellbore placement team, and she's going to be talking about our gyro MWD tools, both our standalone and our modules. And we'd love to see you back in. So thank you again, and stay safe. We'll see you again soon.
Thank you, Ben. Thank you, everyone.